In this video, I want to show how we can use NumPy to estimate the following probability. If you roll 4 distinct 6-sided dice, what's the probability that the biggest value is 5? So let's find a way of simulating this experiment. And I've already imported NumPy, so I'm going to get a default random number generator and save it as RNG with that variable name. And then I can do RNG.integers. 1 to 6 are the possible values, including 6, so I should go 1 to 7 here since the 7 is not included, but 6 will be. And then size, well, what size do I want? Well, I want to roll 4 of these 6-sided dice, so I should do size equals 4. Okay, great. And then let's start out by estimating this probability using a for loop. So let's use a small number of experiments to start. Let's use 10, and S will stand for the number of successes, and for I in range experiments. And so what do I want to do? I want to take one of these arrays of 4 values, 4 random integers from 1 to 6. I want to compute the maximum. So let's do np.max. Okay, you could also do just plain max, but you should imagine that that's probably going to be slower since it's a built-in Python function instead of some NumPy function that's optimized for NumPy arrays. It's possible they would be the same, but in general, you should worry that the built-in Python version will be slower. And so what do I want to do? Well, if this is equal to 5, okay, then I want to add 1 to the number of experiments. Okay, and then at the end, let's just check what's number of successes divided by number of experiments. Okay, so in this case, 3 of the 10 were successful. Okay, great. But it turns out this is quite slow, at least if we use a reasonable number of experiments. So let's go up to 1,000,000. And it's so slow that I'm going to use time instead of timeit. So time is just going to run this once. And while we're waiting for this, let me show you how the timeit output looks. Okay, timeit looks something like this. So it says the average time, okay, mean time, plus or minus some standard deviation. And in this case, it ran 7 times. In this case, it ran 700 times, 7 times 100. And so here you can see it was very slow for like only doing 1,000,000 iterations, took 13.7 seconds. Okay, so let's see a way to make this faster. And one of the things I want to introduce in this video, and like the title of this video is the axis keyword argument. So let me show you how to do that. So let's go back to a small number of experiments, 10. And now instead of doing just size 4, let's do size experiments by 4. So you should think of this as 10 different experiments all in a single array, and each row corresponds to 1 experiment. So this one was a success, this one was a failure because the maximum is not 5, and so on. And so if I want to know like which ones were successful, you could try doing something like, so let's call this ARR. Let's print ARR because it's going to be different from here. And then let's look at np.max ARR. And so the problem is this isn't doing it 1 row at a time. It's taking what's the maximum of all of these values. So let me show you a way to get around this, and we'll eventually have a better way, but let me show you a first way that's more flexible because it can use a wider variety of input functions. And the name of this function I want to use is apply along axis. So the signature for this function is it takes as input the function we want to apply, the axis we want to apply along, and the array. So the array is self-explanatory. That's like this 2-dimensional array up here. The function is pretty self-explanatory. That's our np.max in our case. And the axis is what I want to talk about the most. So for example, if I want to plug in something like this, then that's plugging in along the columns axis. So it's like fixing a row and letting the columns vary, and the columns correspond to axis 1. So if we're plugging in a single column and letting the rows vary, that would be axis equals 0. And in our case, what we want to do is axis equals 1. So let's look at it. So here's the array, and then I can do np.apply along axis. The function we want to apply is np.max. The axis I want to apply along is the columns axis. Okay, so we'll be plugging in something like this. And then the array is ARR. Okay, this is from the documentation. It was called ARR. This is from what I called it. Okay, I also called it ARR. So the maximum here was 5. The maximum here was 6. Here we get 5. Here we get 6. Okay, great. Can you predict what would happen if I changed it to axis equals 0? Well, it's saying, what was the maximum here? Okay, that was 6. What was the maximum here? That was also 6, and so on. And so let's try this. We've avoided the for loop. We do x equals 1,000,000. Then let me just copy it from up here. So we make this ARR. And we can do this apply along axis. Okay, and then, well, let's go back to 10 for a second, and let's just look at what we get if we ask, is this maximum equal to 5? Oh, and do you see what I did wrong here? Because I was expecting to get 10 trues and falses. Yeah, I didn't change the axis back to 1. Okay, now I have 10 trues and falses. And so if I want to get what's the probability of it being true, then there's a nice short way to do that, which is to do .mean. And the idea behind this is it's saying, how often is it true? Because it's thinking of true as 1 and false as 0. So it's adding up all of these values. So that's adding this up, it's the exact same as counting trues. So exact same as counting the number of successes. And then that would be if I did .sum, and if I do .mean, then it divides by 10 in this case. And let's go back to 1,000,000 of them. And I should get a number pretty similar to what we got up above. Okay, where we got this 0.284 or 285. Okay, again, we got approximately 0.285. Perfect. And so let's time this again. And let's see how long that took. And turns out it's still fairly slow, still 5 seconds, which is quite slow for really only doing like 4 million things. So how can we make this faster? Well, the problem is that this apply along axis, that's like very general and it's not optimized. So instead, let me go back to 10 experiments. And then I can show you this. And then instead of apply along axis, this won't work for every conceivable function, but this will work for a lot of the most common functions. I can do .max. Okay, well, that didn't work. Okay, let me try printing ARR. Okay, that didn't work for the same reason doing np.max of ARR didn't work. It's just giving me the maximum of the entire array. Okay, but that axis keyword argument, I can also use that here inside of max. Okay, if I check the documentation, help arr.max, you can see there's an axis argument. And so if I say axis equals 1, okay, then I get maximum is 6. Okay, that's this 6. Towards the middle, I have some 5s. So I guess that's these two. That's where those two 5s are coming from. Okay, great. And so let's do this again. Let's get rid of the print. And then here I want to know how often was it equal to 5. And then I can do .mean. Mean also takes an axis argument, but since this thing is already one-dimensional, okay, it looks something like these trues and falses that, let's see, maybe I've gotten rid of it. Let me show you. So if I get rid of this, so this is what's called a Boolean array, and notice that it's one-dimensional. So now if I do this dot mean, I could do axis. Well, if I try to do axis equals 1, I get an error, and it says axis 1 is out of bounds because there's only one axis total. Okay, but if I do axis equals 0, hey, then that works, but can also just leave it out. And probably won't get 0.4 again, but it's doing the same thing. The only reason I didn't get 0.4 is because I had new random numbers. And so if I do 1,000,000 of these, you can see it was almost instantaneous. And let's time how long this took. Okay, almost very short, like less than 1/10 of a second, which is so much shorter than 5 seconds with the NP apply along axis, and much shorter than the 13 seconds or whatever it was for the for loop version. So this is by far the best version of this code that we've written. And the main thing it used was this maximum method for this two-dimensional array together with the axis equals 1 argument. And that sped things up by a huge amount.